So looking at question 18, we're solving equations from unit 1, 1.2, 1.3. This will be a quadratic equation. So the question says, find the real solutions, if any, of the following equation. It says use the quadratic formula. So since it says use the quadratic formula, we know we have a quadratic equation. So ax squared plus bx plus c is equal to 0. Our equations has to be in this form to use the quadratic formula. The formula itself says I can solve for x using the formula which says to take the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So that's actually the formula. So to use the formula, we have to have a quadratic term, we have to have a linear term, we have to have a constant, and it has to be set equal to 0. So if I look at this equation, I have this 3x times the expression x plus 3, x plus 2 equals 3. So the first thing to make it look like it's in quadratic form is we have to remove the parentheses. So we actually have to multiply the 3x through the parentheses using the distributive property. So we know that 3x times x would be 3x squared, and 3x times 2 would be 6x then. And then this is going to equal 3. Now, we got our quadratic term, our linear term, and notice how it has to be equal to 0. So we have to move this 3 over to the other side. And when we move something to the other side, all this is really has changed sign. So this becomes 3x squared plus 6x minus 3 is equal to 0. Now, I can use the quadratic formula, but what I recognize is each term can actually be divided by 3. So I'm going to go ahead and divide everything by 3 to make the problem a little bit easier. So I'm going to divide the quadratic term by 3, divide the linear term by 3, divide the constant by 3, and divide 0 by 3. In doing so, the 3's will divide out, and I'll have this x squared. And 6x divided by 3x is going to give me a 2x. And negative 3 divided by 3 will give me a negative 1. And then 0 divided by 3 is just simply 0. So my equation turns into x squared plus 2x minus 1 is equal to 0. So to use the formula, the a is the coefficient in front of x squared. So the a is actually a 1. The b is the coefficient of the linear term. It's the coefficient of the x. So this 2 would be the coefficient of the x. So b is going to equal 2. And then the c is the constant, so that's at negative 1. So what I can do now is using the quadratic formula, I can substitute in. Let me move my picture out of the way. So x is going to equal, and the formula says to start with, take the opposite of b. Well, since b is 2, I want to take the opposite of a positive 2, which is going to be a negative 2. And then I have my plus or minus. I got the square root of. And then I have to do b squared, so it's going to be a 2 squared, minus 4 times a, which is 1, times c, which is negative 1. And then I'm going to divide all that by 2 times a. And since a is 1, 2 times 1 is just 2, so I'm going to go ahead and work out the denominator. So the next thing we have to do now is kind of simplify. So the first thing I simplify is what's inside the radical. So on my calculator, I'm going to do 2 squared minus 4 times 1 times negative 1. That looks good. Hit enter. That's going to give me an 8. So x is going to equal then this negative 2 plus or minus the square root of 8 divided by then 2. Now, the next thing we have to do is simplify the radical parts. So we have to simplify the square root of 8. So if I'm using the prime factorization of 8, we know the prime numbers are, again, this 2, 3, 5, 7, 11, and 13. So what I'm looking for are a perfect square, so I need a pair of factors. So 2 goes in 8 4 times, 2 goes into 4 twice, and 2 goes into 2 one time. So the prime factorization of 8 would be 2 times 2 times 2. Now remember, to be a perfect square, if we have 2 of the same factor, we can bring it out of the radical. So what I'm seeing is there is a pair of 2's. So what this tells me is I can rewrite this then as x equals -2 plus or minus, and this pair of 2's is going to come out as a 2. And this 2 is going to be left inside there. So there were 3 2's inside here. I'm going to bring out a pair of 2's as 1. Again, for every 2, you bring out 1, because remember, that's the rule for taking the square root. So I have -2 plus or minus 2 square root of 2, and that's going to be all over then this 2. So our next strategy is to simplify this, is to separate this into 2 separate fractions. So I have -2 over 2 plus or minus 2 square root of 2 over 2. Notice that -2 divided by 2 can actually be simplified. That would be a -1. And notice how these 2's would divide out, and that's just going to give me then this plus or minus the square root of 2. So my answer would be then -1 plus or minus the square root of 2 would be my solution. And that is a real number. So it would be considered irrational, but it would be considered a real number. So x equals then, you can write this as -1 plus the square root of 2, comma, -1 minus the square root of 2 would be the 2 solutions if you want to write them separately. Or again, like you said, you can, in MyLab Math, you can actually type this in as one full solution. So that's going to be your solution set. That's going to go inside the little braces. So the set of -1 plus or minus the square root of 2 would be the solution to that equation. So hopefully you'll find that helpful in doing question 18.